Okay, Assalamualaikum warahmatullahi wabarakatuh. A very good day to everyone. So, today I'm going to brief to you on the chapter 5, which is on the topic of numerical differentiation. So, basically on this topic, what we going to have are two major subtopics contain of first derivative difference formula and also on the second derivative of difference formula. Okay, in the part 1 of my presentations, I'm going to explain on the first derivative, whereby you're going to have a few methods of derivation, which is derivation using the 2 points forward difference formula, 2 points backward difference formulas, and 3 points central formula, or you can use 3 point by forward difference formula, 3 points by backward difference formula, and a selection of 5 points using using difference formula. Okay, we jump to the first point, first derivative of methods for using the Taylor series expansion. So basically, in this subtopic, okay, we are going to fully utilize the Taylor series expansion when we're doing the derivation. So for the first degree of derivation or the first derivative uh, method, we actually going to use only up to the first level of derivation, which contain of fx plus hash f prime x. Okay, so this is the line where you're going to stop when you do the first derivation, because you only need this formula. You only need to rearrange the formula up to the first derivative formula or up to the first derivation, and to find the approximations of fx value, okay, by rearrange the Taylor series equation. Okay, so when you're doing the second derivative formula, meaning that you will do the derivation up to the second levels of Taylor series expansion to up to this level. Okay, so how you going to recognize your derivation level, or how you going to recognize the formula that you need to use to do the derivation is by looking at the prime. Okay, the numbers of prime symbol on your equation. Okay, if you have only single prime like this, okay, meaning that you're going to use the formula for to get the first derivative um, of the first level of derivation value of fx. Okay, but if you see that you have two prime to your f function, meaning that you are doing the second derivation or second derivative for approximation of the fx value. Okay, so but however, you don't have to worry on the formula, because normally in your exam you're going to have one appendix that contain all the formula that you might need to do the solution for the examination questions. Okay, so in this Taylor series equation, you can see a few symbols that has been used. For example, you can see hash over here. So what does hash represent? Okay, for basically hash is the value of interval, or the delta x value, okay, inside the graph. So for example, let's say that you have one set of equation or one set of data. Okay, the hash value is the difference or the intervals between one point to the other point. And normally when you do the derivation, you need to use the same hash value throughout your calculation. Okay, so x, consider that x is your point that you want to find. Okay, for first derivative 2 point formula, meaning that you're going to have 2 points to do the derivation. For example, for the 2-point forward difference formula, meaning that you are here at the center point or at the x interval. So the second point in forward condition will be the point at x plus h, one step ahead from the point that you are standing at. Okay, for 2-point difference formula, meaning that 2-point backward difference formula, meaning that you are going to use the first point, which is the initial point, and the second point is the point at the back of your interval or your current interval. So meaning that you're going to use x and also the interval at x minus h. Okay, so every time you are doing 2-point difference formula, meaning that you going to use only 2 points. Either you use x with the x plus h point for forward formula. This is forward difference. Okay, or you are using the x point with the another interval at the back of x, which is the x minus h interval. This is where we said that we are doing the differentiation using backward difference formula. Okay, so that is how you know which formula to be used. So basically what you have to look into when you want to do the difference procedure, or when you want to estimate the value of a function at one position, so you need to actually define which data that you have. And the first thing that you need to make sure is that you can only use this method when you have a consistent or by using a consistent interval value of hash. Okay, in other words, or in Malay, so if you want to use the derivations untuk menganggarkan nilai function of x ataupun fx value at certain point, so apa yang you kena pastikan adalah you mesti menggunakan sela di antara dua titik ataupun di antara dua interval yang mempunyai sela yang nilainya sama. Maknanya nilai hash ni mestilah konsisten throughout you punya calculation. So you tak boleh ada contoh on the first hash dia punya interval is 0.1 for example, but the second hash you punya interval is 0.25 for example. So tak boleh. So kalau interval you is 0.1, so throughout your calculation you must have data set that have the same interval value. Okay. Okay. Dalam using the first derivative formula, so basically as I mentioned, okay, you're going to approximate the value of fx, ataupun you akan approximate the differentiation of fx value using the Taylor series up to first degree of approximation ataupun first degrees of differentiation. Okay. So this is the simplified formula. So where did this formula came from? Is actually from the slope of the graph. So kita akan tengok kat sini. Okay. The derivations formula is actually came from the slope of the graph. Okay. For example, let's say you ada one exponential graph, okay, that contain two intervals, which is x as the initial point, and then the other point or the other x value that you have is the x plus hash, which hash represent the difference between these 2 points. Okay. Pada 2 point ini, at these 2 points, so you have to estimate the differentiation ataupun you have to estimate the value of fx using differentiation by uh, finding the slope of the graph. Okay. In this case, okay, at the first point, yeah, your x at the x-axis the value is x, but at the y-axis the value is fx ataupun yx. Okay, and then for the second point over here, the x value is actually x plus hash, whereby hash is the difference between these 2 points, and then your fx value is actually fx plus hash. Okay, this is the value that you can find from the data set. Okay. And then to know the slope of the graph, meaning that you're going to use y over x value, delta y over delta x ataupun delta fx divided by delta x. So for the delta fx, the difference between these 2 points is represented by the fx plus hash minus fx plus hash minus fx. So you get the difference value, and then in the x-axis the difference value is actually x plus hash minus by hash x. So you're going to left only the value of hash. Okay, so this is where we get the formula for differentiation of Taylor series. Okay. So the same goes to the 2 point backward. If in the 2 point backwards, meaning that you're going to have your first point or your x, the value at x axis. This is the starting point x, and then you're going to have another point behind the x value, which is at x minus hash. Hash still the difference between these 2 points at x axis. Okay. So again, to find the slope of the graph, but this time because your second point is at the back of your first point, so you have to use backward formula. Okay, in the backward formula, so you still have to find the value of the slope or the slope of the graph by by finding the difference between the first point, which is represented by fx, minus by fx minus hash, divided by the difference at x-axis, which is the x minus hash. So by simplify the formula, okay, you will get the value of first derivative at point x equal to fx minus fx minus hash. This is the delta fx value divided by hash. Hash is actually the delta x value. Okay, and if you are using the first derivative 3-point center formula, meaning that you have the data for or you don't have the data for your central value, okay, but you definitely have the other two points data, which is the data at the front or to the right of your right hand side, okay, which represented by the x plus hash, and also you also have the data at the left hand side, which is the x minus hash. If you have these three data, or if you have at least these two data, you actually can use the first derivative 3-point central difference formula to do the approximation of f prime x value. Okay, and the formula will be given by Taylor series, okay, as f prime x equal to fx plus hash minus fx minus hash divided by 2 hash. So this is the first derivative 3-point central difference formula that you can use to approximate the f prime x value or the derivation value of the fx. So as I mentioned before, you don't have to worry because all formula will be given in your examination. It's just that you have to recognize which formula to be used and which formula is suitable to be used according to the data that you have. Okay, so don't worry, just recognize the formula. Okay, now we go for example on using the 2-point forwards, 2-point backwards, and also 3-point central formula. Okay, the example which I take is from your module on page 123. This is exercise question 4A. Okay, so in this question, they give you that the function of x, the function of fx, okay, is represented by the exponent x equation. And in this case, you have to use the hash or the step size of equal to 10 negative k, where the k value must start by 1 and 2. In this question, you have to find or you have to approximate the value of f prime x. F prime x meaning that you're going to approximate for the first derivative Taylor series equation, okay, for x equal to 2.2 using the 2-point forward, 2-point backwards, and 3-point central difference formula. So in this question, it's very clear stated that you have to use these three equation or these three formula to approximate the value of fx using the differentiation method at the value of x equal to 2.2. So straightforward, you know that you're going to have the three formula which I show you before. So this is the the formula that you're going to use to do the approximation. Okay, but what you need to do, okay, because in this formula, we give you the formula represented by the function of fx and also the hash symbol. For the correct formula, what you need to do you have to replace the function formula into the equation formula. Okay, so this is your first derivative second 2-point forward difference formula, which represent by fx plus hash minus fx divided by hash. So I have to substitute the fx function to become the equation that represent the fx itself. Okay, in this case, so I replace the fx plus hash to the function equation, which is ex plus hash. Okay, and then minus fx is ex, it's powered by x, divided by hash value. Okay, so this is the simplified formula which using the correct function of fx. Okay, so and then the second one, this is the formula for 2-point backward difference formula, whereby you have the formula, the function of f prime x is equal to fx minus fx minus hash divided by hash. So what you have to do, just replace the function fx into the equation of exponent x, because the function of fx represented by the e powered by x, and then minus by e powered by the x over here must be replaced to x minus hash divided by the step size hash. Okay, this is the second formula that represent the 2-point backward difference formula. Okay, and then the third formula that you're going to use is the 3-point central difference formula, whereby this formula, the formula was represented by f prime x, or the derivation of the fx value is equal to fx plus hash minus fx minus hash, which I have changed or replaced the function into the correct equation of ex. Okay, so this, because this is f x plus hash, so I have to replace the x value into x plus hash, and then minus by f x minus hash divided by 2 hash. So after you have create the formula on paper, then you can use your calculator to set the formula according to this function. Okay, so just bring out your answer into a more neat and proper way of presentation. So you can use table instead of you write it one by one. Okay, so for this case, it has been requested in the question that you have to use the step size equal to 10 minus negative k. So this is the step size. So for your k, you're going to start your differentiation for k equal to 1 and 2. So this is where you have k equal to 1 and 2. Okay, this is the step size. The step size was represented by equation 10 minus 10 powered by negative k. So you have to substitute the value to show what are the integrals value. So for this case, for when k equal to 1, so the function of the value of k of hash is equal to 10 powered by negative 1, which equal to 0.1. And for and at k equal to 2, meaning that the step size will be 10 powered by negative 2, which equal to 0.01. So, and then you can straightforward go to your three equation that you have created earlier, okay, over here, and you already set it into your calculator. Okay, so in the form of equation in the calculator, you should set your calculator having the equation of x plus 0 x, the x value you can replace by a plus b minus e powered by a divided by b. Okay, so when you push the calculate, or when you tap on the calculate button, so you can replace the a into x value, which is 2.2, and then you replace the hash being 10 negative, the hash being 0.1. Okay, and then just find the answer. So you can get the answer value of 2-point forward difference formula as 9.4917. The same goes to the second point backward formula. Create this function into your calculator. You can use you can replace the x into a, or you can stick to alpha x or x symbol to represent the x value, and the hash value you can change into other symbols such as b, a, or so on, and then you just tap on the calculate button. So when the x value is 2.2, the hash value must represent the step size, and then you can simply calculate the value for 2 points backwards and 3 point central formula for both k equal to 1 and k equal to 2. So from this table, okay, you can know the error value, okay, by calculating the absolute error or the percentage of relative error value using the formula that you have learned in chapter 1. Okay, the exact solution for the fx value when the x equal to 2.2 can be calculated directly using this formula. Okay, this is the function that you can use to find the value of y or the fx, okay, for the exponential x equation. Okay, when you use the formula straightforward, or when you use the equation directly, you can find that when the value of x is equal to 2.2, the value for fx or the value for y at y-axis will be 9.0250. So how much or how big is the error between the exact solution and the approximate solution? Okay, you can just simply minus exact value to the approximate value. Then you know how much is the error value. Most of the time, when we empower or when we use more points to do the approximation, we might able to get a very small error value compared to when we are using less point to do the approximation. And for the example, so we can see that if you are using the 3-point central formula, so we can get the error as low as less than 0.002 uh, 0.002 compared to the uh, approximate value. So you can do this exercise to test your to test your either you really know or you really understand on what I have explained before. Okay, for this example, so you still using the same equation which represent the fx, and then you only have to add another k value. For this time you're going to have hash up to 10 powered by negative 3, which is 0.001. Okay, and then you have to approximate the first degree of derivation for the function of fx when x equal to 1. Okay, by using the 2-point forward, 2-point backward, and 3-point center difference formula. So please bear in mind that this question required you to give answer in 6 decimal places. So as I mentioned, you can use table as what I did over here, okay, to represent your answer neatly so that it will be easier for your lecturer